Awesome. And the reason I show, there's two reasons. The reasons are twofold. First of all, congratulations on passing Unit 1. Because Bruss taught it, you have done an awesome thing. You actually learned from Bruss teaching. That's the first. Second of all, we're going to be starting a unit of proofs. And to do that, we're going to have to wrestle with some statements. See what I did there? By the way, I think I saw Bruss's face when you fail a mastery check. Let's check it out. Yep. Yep, that's definitely it. That looks like those in Ramstein, you know that looks like Bruss. All right, let's start with inductive reasoning. Now, I'm going to warn you, I'm going quickly, but it's not that difficult. So pause the video like you're supposed to, and then keep up. Make sure you write down any questions in the margin. Here we go. Inductive reasoning is reasoning based on patterns you observe. Let's look at some examples. All right, so basically you see a pattern and you figure out what comes next. That's inductive reasoning. So the first example, we have 1, 4, 16, 64. What do you think? Well, I see that we start at 1 and we do times 4 times 4 times 4. So I bring out my trusty calculator. Do 1 times 4 is 4. All right, well, that gives me the first answer there. And then next, I'm just going to do times 4. What that's going to do, see that little ANS? That means your last answer. So the last answer is 4. I'm going to do times 4 again. I hit enter, and it tells me 16. That's correct. And I look and I hit it again, 1664. So I hit it 2 more times. I'm going to get 256 and 1024. And again, I got those by multiplying by 4. All right, number 2, what do we have? We have a circle. There's no numbers here. So circle, triangle, then square, then pentagon. All right, so if I mean, you just have to look for patterns. Patterns, we have 3, 4, 5 different points. So the next one would be a hexagon and then a heptagon. So if you look at both of these, hexagon, heptagon, we have 6 points and then 7 points. And if you want, you could shade the inside, but I didn't do it. So now it's your turn. Pause the video and you try numbers 3 and 4 all by yourself. Go. Okay, so for 3, if you notice, you just keep drawing circles. Each circle is half the size of the smallest one, and their tangent, that's called tangent when they touch right there. So here are the next 2 shapes in that pattern. And for number 4, did you get it? Did you figure it out? Well, you're dividing by 2. So then the hard part is when you get down to 1. What's 1 divided by 2? Well, divided by 2 means 1 divided by 2 is 1/2. And then you divide that by 2, you get 1/4. All right, so that's inductive reasoning. It's using patterns to figure out, what comes next. And once you figure out a pattern, you can start to make conjectures. Now, a conjecture is a conclusion that's made using inductive reasoning. All right, so let's try to figure out the next pattern. And we're going to try to go down. I mean, the next one might be easy here. Actually, this is easy. We can do this together right now. You're looking, there's a square of size 1. There's a square of size 2. It's 2 times 2 for a total of 4. There's squares of 3 times 3, 4 times 4. So the next one would be, okay, so I've drawn squares of size 5, even though this doesn't really look like a square. I'd have to kind of like squish it in a little more, all right, to make it look like a square. But the question is, can you guess how many would be in the 20th? All right, so 1, 2, 3, 4, 5 would have 25 because it's 5 times 5. That's easy enough. But what would the 20th one have? All right, here's 5. Oops. Come on, little pen. Let's start working. So 5 times 5 is 25, but we want to go out to the 20th one. Well, if you continue the pattern, you're going to have 20 by 20, and 20 times 20 is going to be 400. So that can answer that question using inductive reasoning. All right, so now you try it. Figure out the 43rd term. Okay, don't write down 43 different. I mean, that's what Bruss did. He wrote down 43, but then again, I'm not sure if he has a light. Never mind. But what you want to do is find a pattern here. It's not a hard pattern. You know this since grade school. Find the 43rd term in the following sequence. Go. Did you get an I? Now, how do you get that? Some of you are like, huh? How do you get that? Well, let me tell you the easiest way. The easiest way is I'm going to go down through and number these. All right, so this is the first term and the second term, third, fourth, fifth, and then it repeats. Okay, the sixth, seventh. Let me write out the next couple terms here. A-E-I-O-U. Okay, so that'd be 6, 7, 8, 9, 10. Let's look for a pattern. Okay, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. They're going to repeat every 5. Okay, so I know that the 5th one is a U. The 10th one is a U. The next one would be the 15th one would be a U, and so on and so forth. Well, we're trying to figure out the 43rd term. All right, well, what is a multiple of 5? Okay, 5, 10, 15, 20, 21, 40. The 40th term is a multiple of 5, so I know the 40th term is going to be a U. If I want the 43rd, 1, 2, 3. It's got to be an I, and that's how we figure that one out. We just look for the pattern, and then we keep it going. All right, that's easy enough. Now on to counter examples. Well, sadly, not all of your conjectures are going to be true. Okay, you're going to make a guess and you're going to be wrong. And how do you prove that your conjecture is not true? Well, you need to find a counterexample. A counterexample is one example that shows that your conjecture is false. All right, it's the case where it doesn't work. Okay, for example, like all prime numbers are odd. That's not true. That's a good conjecture, but all prime numbers aren't odd. I have a counterexample. It's the number 2. Okay, that's prime and it's not odd. Okay, it's the only prime number that's not odd, but that would be my counterexample. All right, so let's go through some examples. We need to give a counterexample for each of the following false conjectures. If the name of the month starts with the letter J, like June and July, it's a summer month. Okay, well, that's not true. False. Okay, we also have January. All right, so that would be the counterexample. It's the example that's not true. All right, 2, multiplying a number by 2 makes it bigger. Well, let's see. Multiplying a number by 2 makes it big. What about negative 10? If I multiply it by 2, it would equal negative 20, and that's not bigger, that's smaller. So that would be my counterexample there. You try it. If you teach flip mastery geometry, you are super good looking. Figure that. That's your example. Pause the video and do that one. Go. Okay, we're back. Hopefully you came up with the only right answer, which is Brust. Hey, I know I'm picking on Brust today, but he's such an easy... I mean, it's just a target I can reach. All right, next part, conditional statements. All right, so we basically finished the first half of the video. Okay, that's the first half. Just go absorb that, and we're moving on to conditional statements. A conditional statement, they're extremely useful because it's a statement that can be written as if-then. Huh? All right, so the first example. If you complete an entire packet on your own, then you will pass the mastery check. It tells, the first part's called a hypothesis. Okay, so let's write that down. Hypothesis. That's the first part, the if part. If you do this, then it tells you what's going to happen second. Okay, after the first part. Okay, so that's called a conclusion. Conclusion. We're going to get to that a little later too. But this part's the conclusion. You'll pass the mastery check. Okay, how about number 2? If you drink coffee late at night, you will have trouble sleeping. All right, that's an if-then statement, but you're not writing the then. But you can write the then, and if you did, it'd be right there. Okay, if you drink coffee late at night, then you will have trouble sleeping. Therefore, this first part is the hypothesis, and the then part, that's the conclusion right there. Okay, how about 3? When Sully stays up late, it's to catch Santa Claus. Okay, let's change when. I mean, you're going to have to be smart enough to rewrite these. If Sully stays up late, okay, then he is catching Santa Claus. All right, so these are conditional statements. Oh, how about the dolphins one? Dolphins are mammals. What? That is not if then. Ha. If you are a dolphin, then you are a mammal. See how I rewrote that? You have to be smart enough to read this thing, figure out what it means, and then reproduce it in an if-then sentence. And that's called a what? A conditional statement. Conditionals based on the condition if you're a dolphin. All right, so you try these 2 all by yourself next. Randy Macho Man Brust. Okay, hopefully you paused the video, you figured these 2 out. Quadrilaterals have 4 sides. So that means that if a polygon is a quadrilateral, then it has 4 sides. So there's my if-then statement there. That's a conditional statement. Parallel lines never intersect. So if the lines are parallel, then they never intersect. That's a conditional statement. It's easy. You just go if, then. You just got to figure it out. You got to make sure you go in the right order, too. The order that they give it to you. Important. It is super important. And the reason why you're going to find out in just a few minutes. We're going to move on to the actual technical names of the if part. The if part is called the hypothesis. And the then part is called the conclusion. All right, it's that simple. So each one of these conditional statements, the if part. So if Sully shoots a ball, then the shot will be an air ball. If Sully shoots a ball, that part there is called the hypothesis. I'm going to underline it, put an H there. The then part, then the shot will be an air ball. That's the conclusion. Hey, it's that simple. Let's try number 10. If a triangle is equilateral, then it is also isosceles. If part, that's the hypothesis. then part. That's the conclusion. Okay, we're concluding that it's isosceles if it's equilateral. So if the first part is true, then we know the second part's true. And that's why they're called conditional statements. It's a condition that must be met, and if it is, then we know the second part is true. Sometimes they might flip around the order, and you have to be careful. I rewrote number 10 in a tricky way. Ooh, careful. A triangle is isosceles if it is equilateral. There's a statement, but the if part's right here. If a triangle's equilateral, I know it doesn't say a triangle, it says it, but if a triangle's equilateral, that would be our hypothesis, then it is isosceles. That would be our conclusion. So I would circle that part there. How easy is that? It is super easy. Let's move on to related conditionals. We're not talking about your mother's brother's uncle's cousin. That's not relate. Well, that is related, but we're talking about, statements that are kind of close, but I guess that's a relation. Kind of close, but not exactly the same. All right, first thing we need to learn, a negation. It's the opposite of a statement. So if I give you the negation, it's opposite. It's putting the word not in there. So let's pretend like P stands for breast is pretty. All right, so the negation of that, we'd write this. P stands for pretty. Breast is pretty. Okay, the negation would be not P, so we could write it with words, or we can use this little tilde thing. That means breast is not pretty. All right, so let's use the following conditional to help us illustrate some examples. If I studied really hard, then I earned an A on the test. So it's not asking us to, but here's the hypothesis, here's the conclusion. All right, I'm going to get rid of all that stuff so that we don't have to look at it, but this is a conditional statement, if, then, and the way I can write it is right here with letters. We can abbreviate. If, there's my S, if I studied really hard, then, that's what that arrow means. If the first part, then it takes me to the second part. Then I earned an A on the test. All right, so let's learn about some of these related conditionals. The first one, it's called the converse. All right, the converse is where you switch the order of the two different parts here. So remember, the hypothesis is I studied really hard, then I earned an A on the test. If you switch the order of two, then you have a new hypothesis and you have a new conclusion. So what would this mean? This would mean, and I'm looking at these symbols here because that's easier for me. If I got an A on the test, then I studied really hard. That would be the converse. Now, the way I always remember converse, all right, we had these Chuck Taylor All-Star shoes. All right, they were Converse. Converse made them. They're sneakers. And I always remember on the basketball court, you'd switch directions really fast. If you had your Converse on, you'd go from there to there to there. Okay, you're switching directions. That's exactly what you're doing here. You're switching the order. I don't know. Does that work for you? It worked for me. Maybe it doesn't work for you. Next one. It's not called the converse, but the inverse. Whoopsie. Get rid of that. The inverse is if you take the opposite of both. You negate both of them. So I would read this as if I don't, or I didn't study really hard, then I didn't receive an A on the test. Okay? That's the inverse. And again, we're always going back to that original conditional statement, which is right here. All right, the inverse is you make both of them the opposite. If I didn't study, then I didn't earn an A. And the last one's got the most letters, and it's a super hard word, contrapositive, so you must have to do the most, and that's true. You have to flip it, and you have to negate it. So you make it the opposite, and you change the order, and that's called the contrapositive. If I didn't earn an A, then I didn't study hard. All right, now something you should know. The conditional statement, all right, this may be true. If I studied real hard, then I earned an A. All right, let's pretend like that's true. All right. If that is true, then the contrapositive will also always be true. And the converse and inverse, they also have the same truth value. Okay, so if this is true, if I earned an A on the test, then I studied really hard. You know that might not always be the case. You might always get A's no matter what without studying. All right, so if the first one is true, suppose you're one of those genius kids. Okay, Sully. If you study really hard, then you earn an A. All right, well, if they study really hard, maybe they're going to get an A anyway, but that's still true. If they study, they're still going to get an A. But just because they got an A, it doesn't mean that they studied. All right, so that's kind of where we're going here. Like, you have to be really careful in what you say, what you write, and what you mean. You just can't throw down anything on the paper and be like, close enough. So, what do you have to get out of this whole part? All right, this is what you have to get out of this whole part. I know there's a lot here. Let me erase this stuff. What you have to get is they're going to give you a conditional statement, just like this. You have to be able to write the converse out, like words, like you're writing it out, blah, blah, blah. And to do that, you have to switch the order. The symbol's not so important, okay? But if you can look at this and say, all right, here's the hypothesis, here's the conclusion, I switch the order, that's the converse. Okay, so if I earn an A on a test, then I studied really hard, that's the converse. The inverse, making them both the opposite, but you don't switch the order. So if I don't study really hard, then I didn't earn an A. That would be the inverse. In contrapositive, you switch it and you make it the opposite. All right, if you can do that with a conditional statement, you are good to go. All right, now I'll give you a summary here of related conditional statements and what they mean so you can help. I mean, this might help you study. It might not help you. The inverse is where you make them both not. Okay, we always start with an if P, then Q. Mind your P's and Q's. All right, so that is where that comes from. Man, we are almost done with it. We are done. Hey, that's the whole thing. This was a lot of information. I hope you paused the video and you got it all down. But as I said before, it's not difficult. You're not cramming like square roots and inverse logarithms. So just go through, do the practice. You'll be good to go for the mastery check. Hey, this is Mr. Kelly Baumholder. Remember, it's nice to be important. It's more important to be nice. See ya.